A standard wooden pallet weighs about 30 pounds but can hold 4,600 pounds of freight. That ratio is not an accident. It is the result of 80 years of engineering locked into a design most people treat as trash. Here is what you are going to learn. Why the gaps are exactly where they are. Why 9 blocks hold more than solid wood. Why forklift tines dictate almost every dimension. And why a single international standard nearly broke the global shipping industry. Most people assume pallets are just rough lumber nailed together. Scrap wood, basically. You see them stacked behind grocery stores, used as backyard furniture, posted free on Craigslist. The design looks crude, almost accidental. But the pallet you see today, the GMA standard pallet, 48 inches by 40 inches, 9 wooden blocks, 3 boards on top, 3 on the bottom, arrived at those specific numbers through a brutal process of real-world failure. The U.S. military needed to move enormous volumes of supplies during World War II faster than human hands could manage. They had forklifts. The forklifts needed something to grab. And everything before the standardized pallet, every ad hoc skid and lumber sled, kept breaking, jamming, or failing under load. What emerged from that pressure was a design that looks simple, but is mechanically precise. Start with the gaps. The deck boards on a standard pallet are not evenly spaced for aesthetic reasons. They are placed to balance 2 competing needs: surface coverage and airflow. If you close up all the gaps, the pallet becomes heavier, more expensive to build, and traps moisture. Wet wood rots, warps, and loses structural strength fast. A pallet sitting in a cold warehouse with condensation and no airflow can lose meaningful load capacity within weeks. The gaps allow air to move across the entire surface, so the wood dries uniformly. More importantly, those specific gaps, roughly 1.5 inches to 2 inches wide depending on the configuration, are sized so standard stretch wrap and banding straps can thread through and secure a load from below. The gaps are not leftover space. They are an integrated fastening system. Now look at the entry points. A standard GMA pallet has 4-way entry. A forklift can approach from any side. A 2-way pallet, which still exists in some food-grade and pharmaceutical applications, can only be entered from 2 sides. 4-way entry sounds like a small convenience, but in a real distribution center where a forklift operator is turning a 10,000-pound load in a 12-foot aisle, the difference between 2-way and 4-way entry is the difference between a 5-second pickup and a 90-second repositioning maneuver. Multiply that across 500 pallet movements per shift in a large facility, and you are talking about hours of recovered labor per day. The tine openings on a GMA pallet are 3.5 inches tall. That is not a standard lumber dimension. That is a number derived directly from the ISO standard forklift tine cross-section, plus clearance tolerance for a loaded pallet that has deflected slightly under weight. The pallet was designed around the machine, not the other way around. The 9-block construction is where things get structurally interesting. Those blocks, corner blocks, edge blocks, and one center block, create what engineers call a semi-rigid frame. When a forklift lifts a loaded pallet from the side, the deck boards are in tension and the blocks are in compression. If you removed the blocks and used a solid wood skid instead, the load path changes entirely. A solid skid is stiffer along its length but dramatically weaker in torsion. It twists under asymmetric loading. A block pallet distributes point loads across 9 compression columns and lets the deck boards flex slightly without transferring that flex into a catastrophic shear. The southern yellow pine most commonly used for GMA pallets has a specific gravity of about 0.59 and bending strength that tolerates that flex cycle repeatedly. It is not the hardest wood. It was chosen because it is abundant in the American South, grows fast, and nails without splitting when green. The design was optimized for the available material, not the ideal material. Here is where it gets messy. In the 1960s and 70s, the International Organization for Standardization tried to establish a single global pallet size. 6 sizes were approved under ISO 6780. The problem: North America had already built an entire infrastructure around 48 by 40. Europe had built around 1200 by 800 millimeters, the EUR pallet. Australia had its own size. Each region had designed its warehouse racking, its truck beds, its shipping containers around a different footprint. The ISO standard did not replace any of them. It just added official recognition to all 6. Today, a U.S. truck trailer is 96 inches wide, which fits exactly 2 48 by 40 GMA pallets side by side with almost no wasted space. A European truck is built around the EUR pallet in exactly the same way. The pallets did not fit the trucks. The trucks were built to fit the pallets. That is how entrenched the standard became. The failure case is heat treatment. Since 2002, the International Plant Protection Convention has required that all wood pallets used in international trade be heat-treated to 56 degrees Celsius at the core for 30 continuous minutes. The reason is pine bark beetle and other wood-boring insects that were traveling inside raw pallets from continent to continent and devastating forests on arrival. The problem is that heat treatment changes the wood. Treated pine is more brittle, slightly more prone to splitting at the nail points, and loses a small amount of its flex tolerance. Cheap manufacturers cut corners on treatment time or temperature, and the result is pallets that pass inspection but fail under dynamic load on a shipping container crossing the Pacific. In 2006 and 2007, a wave of pallet failures in U.S. distribution centers was traced back to undertreated imported pallets that looked compliant but were structurally compromised. The certification mark, the IPPC stamp, became a critical quality signal that most logistics managers had never thought about before. This same logic, design shaped by the tool that handles it, shows up everywhere. Wine bottles are sized to fit a human hand and stack in a specific case count. Brick dimensions in the UK are set, so a mason can lift one in each hand with mortar clearance. ISO shipping containers are sized so they stack on rail cars and stack on ships without a single inch of wasted structural capacity. The handling system always ends up shaping the object being handled. A pallet is not scrap wood. It is a precision instrument built to match a forklift, a truck, a warehouse rack, and an international treaty, all at once. If this is your kind of thing, the why behind the everyday object theory drops new ones every Monday, Wednesday, and Friday.